So this is the second of our two videos on synthetic division, and we are going to be looking at two more examples that are a little bit more complicated than the two that we started with. And the first one here, we're looking at a situation where we're dividing by a quadratic instead of by just a linear factor. So you can see we're dividing 2x cubed minus 5x squared plus x plus 9 by the product of x plus 1 times x minus 2. And what I want you to realize is that in order to perform this division, we can divide that dividend by those two linear factors in succession, right? So we can first divide by x plus 1 and then divide by x minus 2. And you can see that I've set up the division by x plus 1 here in order to save some time. And when I do that division, so this is what I get, right? My quotient is 2x squared minus 7x plus 8 with a remainder of 1. Now what I want to do, I'm going to pause here in the division for a minute and write down what this means in terms of our original problem. And let's do that over here, let's say, right? So what we're saying is that 2x cubed minus 5x squared plus x plus 9 is equal to the quotient 2x squared minus 7x plus 8, and I'm going to run out of room, times x plus 1 plus 1, right? So that's what this is saying, right? We've expressed this divisor, this polynomial, as this quotient times this divisor plus this remainder, right? Now, we also want to divide by x minus 2. But we want to think about how we're going to accomplish that, right? We're going to do a second synthetic division, but this time we're only going to be dividing this quotient by x minus 2. And the reason for that is that this 1 is already of a smaller degree than our divisor. So it's already going to be part of the remainder, if you will, if that makes sense. So hopefully that'll become more clear as we finish the division. But what I want you to realize is we only need to divide this quotient by the second divisor here because this is already part of the remainder. Let me erase this so that it's a little less cluttered, and I'll be rewriting that later. But now, like I said, I'm going to do a second synthetic division. And I'm going to be dividing by x minus 2, so we're going to use 2 there. Again, a 0 here, 2, 4, negative 7 plus 4 is negative 3, 2 times negative 3 is negative 6, and 8 plus negative 6 is 2. And so we get a second remainder here of 2, okay? This is now the new quotient, right? Q of x, if you will. And this is our new remainder, right? But this remainder is different than the first remainder in that it has to be multiplied by the first factor. And let me show you why. So we'll come down here, and we got out of this first division, I'm only going to write this portion of it, I'm not going to rewrite the polynomial. We got out of this first division a quotient of 2x squared minus 7x plus 8, and remember that was times x plus 1 plus 1. And this expression, if we multiplied it out and expanded it, would give us our original polynomial. But now the second division, what we've done is we've expressed this quotient as 2x minus 3 times x minus 2 plus 2. And if you want to pause and convince yourself, right, that if we expanded this expression, we would get right back to here. Okay, so this is equivalent. But now we're going to tack on the rest of this, right? In order, this by itself just gets us this original quotient. To get the original full polynomial, we have to finish the expression, right? And so that's an x plus 1 plus 1, right? And this, expanded and simplified, would give us the original polynomial, right? Now, you can see from this expression that this remainder of 2 that we had here in order to get us back to the original polynomial, multiplies the first divisor, right? Because it was part of this first quotient, right? This remainder is part of this quotient, and this quotient was multiplied by x plus 1. This plus 1 was not part of this quotient, and so it doesn't need any modification, right? This remainder was already part of the remainder. It's separate, if you will, right? And so if we expand this out, well, we're not going to expand it out fully, but if we simplify it a little bit, we can see what the expression would be if we're dividing by these two factors simultaneously, right? What we're going to get is the second quotient, 2x minus 3, times x minus 2. Great, so far so good. But then this whole thing, right, this x plus 1 gets distributed to both of these terms. So this is times x plus 1, right? And there's our final quotient with the final divisor, plus 2 times x plus 1, plus 1, right? So plus 2 times x plus 1 is 2x plus 2, plus 1 is 2x plus 3. And there's our remainder, right? So we got a quotient, the full divisor that we started with, plus the remainder, which we can see is of degree 1. That makes sense because our divisor was of degree 2. And so that's how we perform a synthetic division when we have multiple factors that we're dividing simultaneously. Simply do them in succession, recognizing that the final remainder, multiplies the factor that had been divided before for this reason, right? And I like to kind of sort of write this out so I can see that clearly, and hopefully you can see how this quotient gets rewritten in terms of the second division, right? And if we had multiple, right, we could do this with any number of linear factors, and this expansion would continue, right? So there you go. That's how you handle one with multiple linear factors. Let's look at one last problem. In this last example, we're going to do a little bit of a different problem. Here we have a polynomial that is expressed in powers of x, where each term in the polynomial is a coefficient times a power of x, and we're being asked to rewrite this polynomial in terms of x minus 2. So what I want to do is convert this polynomial from powers of x to powers of x minus 2, so that each term in the polynomial is a coefficient times the quantity x minus 2 to a power, right? So whereas this polynomial is 2x cubed minus x squared plus x plus 1, the answer that I'm looking for will be some coefficient times the quantity x minus 2 cubed plus some other coefficient times the quantity x minus 2 squared, etc., right? The way we accomplish this is to repeatedly divide the polynomial by x minus 2 in this case, the divisor we're looking at. And you can see I've taken the liberty of doing the first synthetic division to save us some time. And I've gotten a quotient here of 2x cubed plus 3x plus 7 with a remainder of 15. We're now going to divide that quotient again by x minus 2. And we'll see why we're doing this as we finish the problem. But we've got 2, 4, 7, 14, 21. So I've got a new quotient and a new remainder. This quotient is 2x plus 7. 2x plus 7 can be divided by x minus 2. So I'm going to do that division one more time. X minus 2, 0, 2, 4, 11. So I've got a quotient of 2 and a remainder of 11. 2 is not divisible by x minus 2, so I'm not going to divide anymore. I'm all done. But what I want to do now is look at each line in succession of this division, this repeated division, and see what it really means for us, right? Each line is a re-representation of this polynomial after repeated division by x minus 2. So this first division, right, what is it saying? It's saying we have a quotient of 2x squared plus 3x plus 7, 2x squared plus 3x plus 7. That quotient is the result of dividing by x minus 2, so that's my divisor, plus my remainder, right? And again, this goes all the way back to p of x is q of x times the divisor of x plus the remainder, right? That's all I've done here. Quotient, divisor, remainder. Okay, fair enough. If we expanded this, we'd get back to here. Everything's great. Second line. Well, what have we done in this second division? We've divided the quotient, again, by x minus 2. The remainder's done, right? This remainder we haven't done anything with. It's off to the side. We've taken this quotient and divided it again by x minus 2. And what was the result there? Well, we got a 2x plus 7. That is the quotient after having divided by x minus 2. And that division yielded a remainder of 21. But this expression that I've just written is just this quotient, right? Expressed in terms of a division by x minus 2. So it's only that piece, right? So that whole quotient had already, we have to incorporate what we've already done in the previous line. This x minus 2 plus the 15. Okay. Now again, if we were to expand all of this, we would get back to here, right? Expanding this would get us to this. Expanding that would get us to there. Okay. We did this yet again, right? But again, we only divided the quotient, the 2x plus 7, by x minus 2 again, right? So when we did that, we got a new quotient of 2, which was the result of a division by the divisor x minus 2, and a remainder of 11. But that is just 2x plus 7, right? You can tell 2 times x is x, 2 times negative 2 is negative 4, negative 4 plus 11 is 7. So this is just 2x plus 7. That 2x plus 7 was multiplied by x minus 2. And there was a remainder of 21 at that step. And that was multiplied by an x minus 2. And there was a remainder of 15 in the first step, right? So now if we expanded this whole thing, we would get back to where we were, right? Expanding this gets here, expanding that gets back to here, expanding that gets to the original. Well, from this step, we can now produce the polynomial in terms of x minus 2 instead of in terms of x. And the way that we do that is sort of by partially expanding, if you will. But it's actually easy to see from just looking at this, right? Let's start from the x minus 2 cubed term, right? I've got 2 times x minus 2. But this 2 times x minus 2 is going to get multiplied by x minus 2 again. So this is 2 times x minus 2 squared, right? Because this is going to distribute both to the 11 and to the 2x minus 2, right? This x minus 2 distributes. That is then going to get multiplied again by yet another x minus 2, right? So this term, this first inner piece here, becomes 2 times x minus 2 cubed, right? That's the full distribution of this piece of it. Multiplies to this, multiplies to that. Now let's look at the 11, right? This 11 gets multiplied by x minus 2. But that piece then, again, is going to get multiplied by this x minus 2, because it's going to distribute as well. And so we're going to get 11 times x plus x minus 2 squared, right? That's the only squared term, right? Convince yourself of that. This was the only term that produces a cubed of x minus 2. This is the only term that produces x minus 2 squared. So plus 11 times x minus 2 squared. We've taken care of the full distribution of both of these most inner terms here, right? And likewise, this x minus 2 has been fully distributed. So we're done with all of this. We come back to the 21. It still has to be multiplied by this x minus 2. And it's the only coefficient that produces an x minus 2 to the first term, and then plus 15. And so now this is the original polynomial expressed in terms of x minus 2 as opposed to x itself, right? Powers of x minus 2. And so there you go. This is the answer to that question. Why would we want to do this? You might have a situation where you have a time, right, and you want to sort of center it on a later time or an earlier time. So you're going to add or subtract 2 or some other value to that to get something in terms of that. It's just sort of a nifty trick, I guess, to express that in terms of an offset as opposed to the original variable itself. That should cover everything that you're going to see in your homework. So hopefully that gives you a good starting spot, and you're in good shape. So good luck.